The curve crosses the x-axis at point A. So what that's telling me is that y is 0. So I'm looking at my y equation here, and I know that needs to equal 0. And now we just need to solve this. So I'm going to, first of all, get rid of that fraction. I'm going to multiply through by 2t. So 0 times 2t will still be 0. The 5 over 2t is now just 5. The 10 times 2t is 20t. I'll subtract the 5 from both sides and divide both sides by 20. So t is going to be minus 1 over 4 when the curve crosses the x-axis. I can now substitute that into my x equation to work out what the x-coordinate is when it crosses the x-axis. So x is 4 times minus 1 over 4 minus 1 is minus 1, which is minus 2. So that's telling me that the curve is going to cross the x-axis at the coordinate minus 2, 0, when t is minus a quarter. So that's part A done. Part B says to show that the equation of the tangent to the curve is 10x plus y plus 20 equals 0. So tangent, so I'm thinking y equals mx plus c, and I need to differentiate to get my gradient function. So we know differentiating parametrically, we're going to do dy by dt divided by dx by dt. The dy by dt, to differentiate this, I first need to write it in a form that can be differentiated. So I'm going to rewrite it as 5 over 2 t to the power minus 1 plus 10. Just taking that t off the bottom, moving it onto the top of a minus 1 power. So now I can differentiate that. So dy by dt is minus 5 over 2t to the minus 2, and the 10 disappears. So that's my dy by dt. My dx by dt, so differentiating here, will just be 4. I can simplify that a little bit because the minus 5 over 2 divided by 4 is minus 5 over 8. And we've now got an expression for the gradient function in terms of t. And we're looking for the gradient at point A, which is where we know that t is minus a quarter. So if I plug that in, and work out what that's going to be, we get minus 10. So the gradient of the curve at that point is minus 10, which means the gradient of the tangent is also minus 10. So y equals mx plus c, and we're looking for the tangent at the point when y is 0 and x is minus 2. So plug that in, and so we find that c is minus 20. Therefore, the equation of the tangent is y equals minus 10x minus 20, and then we can add all of that to the other side to get it in the form that the question asked for. And so that's part B. of this question done. Part C, we want a Cartesian equation for the curve. So we want y as a function of x. So what I'm going to do is I'm going to take my x equation here and I'm going to rearrange it to make t the subject. So I'm going to add 1 to both sides, and then I'm going to divide both sides by 4. Now I know that t is equal to x plus 1 over 4, I can plug that into my y equation here. So y is equal to 5 divided by 2 lots of the t, which I now know is x plus 1 over 4, plus 10. Now this is a bit awkward here because I've got a fraction inside a fraction. But that's okay, I can deal with that, I can simplify that, because if I times the bottom and the top of this equation, of this fraction by 4, then that's going to get rid of that fraction there. So that will be helpful. So that's going to leave me with the 5 times 4 is 20. As I said, those 4's on the bottom have cancelled out. And so I've just got the 2 lots of the x plus 1, which is 2x plus 2, plus the 10. Now to get a common denominator and simplify. In fact, I could simplify first. I could divide the top and the bottom here by 2 just to make those numbers a bit smaller. And like I say, now to get a common denominator, just to get this in its simplest form. So I'm timesing the top and the bottom of the second fraction by x plus 1, so that we've got x plus 1 on the denominator. And we get 10x plus 20. Could leave my answer like that, could factorise a 10 outside, doesn't particularly matter. The question doesn't say exactly how we need to leave our answer. So either of those two answers at the end are perfectly fine. Either of these answers here are perfectly fine.